Hi, so this is my waterproof remote control. It's, yeah, at least you have a magnet, maybe you can see it here, and a hall sensor inside. And what you do is you have it in one hand and, yeah, try to put the fingers here, and you can use the trigger, just elastic here, and you bring the magnet closer or further away. So it's just elastic spring, more or less. The on and off switch is back here. So what I have here is some kind of safety leash attachment. There's also a magnet. Inside you have a read sensor. And what I do, that's the wrong side. What I do is put this thing here in the right position inside, and it will start up. So it's on then. And if it's not at the right position, it's not on. So right now it's on. I have a indicating LED which shows me that it's on, and as soon as I will lose it out of my hand, for example, and it will move it away and it will turn off. So this is the receiver, pretty small. The parts that are inside here in the center, I have a Arduino Pro Mini and an RF24 module. This is here on the sender side. On the receiver side, I have a Nano, Arduino Nano, and the same transceiver, the RF24. This works with 5 volts. This one with 3.3, so I have a lithium-ion battery inside. And then I use one of these single cell BMS boards to care about voltage and don't discharge the battery too much. But the whole case is completely sealed. I have a seal here in between cover and body. This is glued together. I used ABS and then some acetone just to close up every possible, it's 3D printed, so every possible cavity here, at least at the surface. That's why I used ABS for the casing, just to have the option to use acetone to smooth everything and close all the gaps. This one is more elastic. It's made of PETG, also 3D printed, but much more elastic than the rest of the housing. So let's start it up. This is the receiver. This is an ESC with a back function, and I connect these 3 cables. That's minus 5 volts and signal to it. So let's connect it. Minus 5 volts and signal. Now it's connected. As soon as I connect the battery to the ESC, it should calibrate. That's the first sequence in the initialization. The motor gets calibrated. The center is off, and that's why we should have no rotation. As soon as I put the safety leash here on, the center is turned on, and I have some time to calibrate it, so I have to move it to full length here. And now I can control the motor here. And the good thing is I have a green indication that everything works fine. As soon as something loses connection, like for example the receiver have no connection anymore, I have a red indication that the connection is not there anymore, because it's replying to the sender. And as soon as I lose it out of my hand, it turns just off. Right now it's programmed that it will stop as soon as there is no signal for 1/10 of a second. And if I have movement of the motor, it's just a little, because it's calibrated really hard on the edge. So if I just touch it a little, so that's it. If it's off, no rotation. Now let me disassemble it. I have 4 screws here. So what we have here, this part is completely flat. It's 3D printed, pretty simple. Here I have a seal which is glued together. It fits perfectly inside. I just cut it in the right length and glued it together. This is the way the seal is placed. So as you can see, it will cover it and be completely sealed. The PCB is again screwed on with 4 screws. Here's the module I've talked about, the RF24. It's outside here under the cover. So here I gotta be a bit more careful. There's a lithium-ion battery. It's 600 milliamps, which is enough for 30 hours of operation. At this part we have the Arduino Pro. This is the BMS, if you want to call it like this. Here you have the read sensor, which senses the magnetic field at least at this location. So this is where the magnet gets sensed. The B color LED, and this is the on and off switch. If I use my leash here, then if I come closer at some point, it turns off and on. And they are pretty sensitive, so I had to use like 7 of them just to get one working. It felt like if I get too close or just mechanically pull a bit too much, they're broken. But now it works pretty fine. One more important thing, it's of course it floats, so I hope that even if I lose it, I will find it on the water again. This is, I think, one important thing. This, by the way, is the first generation. It was the first generation, or the first iteration. It looked a bit different here, the magnet, but it was too big for my hands and yeah, not handy. That's why I made this one much smaller, so I can have it here really good in my hand, and even for the fingers I got some space. So now it works pretty good. Yeah. And I can look at the LED while I'm operating.